Okay, so we're going to do 7.1 in our college algebra section, and it starts off with systems of equations. And the first thing we're going to do is we're going to say, okay, test these two numbers, and this is 4 is your x and 7 is your y. It's just like a coordinate point. So we're going to see, is this a solution to both equations? So to put it in here, we do 2 times 4 plus 7. Does that equal 15? And then 3 times 4 minus 7. Does that equal 5? 2 times 4 is 8. 8 plus 7 is 15. So, yes, this is a possible solution for 2x plus y equals 15. Then we're going to see, does it work for the other equation? 3 times 4 is 12. 12 minus 7 is 5. So yes, 5 does equal 5. And what this means is that we know for certain that these two at least share this point in common when we are graphing it. So we know at least it looks like that. So when we're testing systems of equations, we think about 3 different possible solutions. And the first one is independent. And really we're going to think of this as 1, none, and infinity. So independent means there's one solution, and it means it looks something like this, where you have 2 points, and 2 lines, and it crosses at one point. Then we have inconsistent. Inconsistent looks like this. They are parallel lines. So inconsistent, you think about, okay, they never intersect, they never share possibilities, so they have to be parallel lines. And what dependent is that if I have one line, and then for whatever reason, I am given the same type line, but it's written in a different form, we'll see this, and it's literally the same line again. And in this case, there's an infinite solutions, because every single point on that line is a possible answer. So let's go through, hopefully you've seen this possibly in an earlier test, Algebra 2 possibly, or taking pre-cal. First we're going to do something called substitution. So what we're trying to do is, okay, we have 2 different lines. Is there a solution for these that could work for both of them? What do they intersect? So first we're going to do substitution. And in this case, we want to solve for a variable. And typically we look at, okay, x, 2x, 3y, and y. This is actually already solved for y right here. So what I could do is I could take this whole entire thing and substitute here for y. And then we just solve this. So we got rid of y, now we're solving for x. X plus, we're going to distribute 3x minus 27 equals 8. Combine like terms, and then we're going to add 27 to both sides. All right, this is going to give us 4x is equal to, this case, 35. Oops, I did something wrong here. So let's go back a sec. This is not 3x. This is 6x. There we go. Makes that 7x. So divide by 7. X is equal to 5. Then I'm going to place it back into any equation. But what I'm going to do is I'm going to take this equation down here. I'm going to say 2 times 5 minus 9 equals y. And we just continue, and we say y is equal to 1. The next one we're going to do is say the exact thing. We see that this one's already solved for x, so I'm going to place y plus 3 where the x is in my second equation. So 4 is equal to 3 times y plus 3 minus 2y. Let's see if I can do my distribution right in this one. So 4 equals 3y plus 9 minus 2y. We're going to combine like terms, so 3y minus 2y is just y, and then we're going to subtract 9 from both sides. Gives me negative 5 is equal to y. Again, I'm going to put that back into the equation of x is equal to negative 5 plus 3, and x is going to equal negative 2. Okay, so that's substitution. If, for instance, if one of them wasn't already solved, we would need to isolate either x or y, and you can choose which one you want. Next one we're going to do is solving by combination, and this one we're combining. We can either do addition or we can do subtraction. It doesn't really matter, but I personally like to do addition because it just seems to be easier. We don't make as many mistakes. In this case, if we add these two together, the x plus negative x cancels out. 3y plus y gives me 3y. And negative 1 plus 3 is 2. And then we divide by 3, and y is equal to 2/3. Now, I know we don't like fractions. We could actually go back and fix this a little bit. What if I were to multiply the bottom one by negative 2? So I'm going to say, let me change colors. What if I were to multiply this one by negative 2? That would give me a 2x minus 2y equals negative 6. And as you see, these cancel, the y's cancel, and then we get 3x equals negative 7. Divide by 3, and x is equal to negative 7/3. So with solving by combinations, I could go back and forth and do it both twice. I could have, if I wanted to, as well, I could have put this 2/3 into the first equation, and solve for that. Now we're going to do something with fractions. And as I always like to do, I like to get rid of my fractions first. So I say, okay, what is my common denominator in this first one, which is 6? So if I multiply everything by 6, that gives me 2x plus y is equal to 18. This one down here, my common denominator is 4. So that gives me 2x minus y equals 4. This ends up being really nice because, as you see, we have a positive y, negative y. If we add them together, that gives me 4x is equal to 22. When we divide by 4, x is equal to 11/2. Now again, we could have, if we wanted to, instead of putting 11/2 over, we could say, well, what if I were to go back to my original problem, and I take this one, and I multiply that by negative 1. Well, now I'd get 2x plus y equals 18. Negative 2x plus y is equal to negative 4. Well, now my x's cancel. So now I get 2y is equal to 14. Divide by 2, and y is equal to 7. I don't need to do that. If I'm okay with dealing with fractions, I could have put this back into either one of these, which wouldn't have been too bad because we would have multiplied it by 2 first and we would have gotten 11, so it wouldn't have been that bad. But if you don't like that, then it's okay. This next problem, we're going to do however way we want to. But I kind of see something that's kind of strange. So let's just say we're going to do substitution. This one's already solved for x, so I'm going to substitute it down here, which gives me 9 minus 2y plus 2y is equal to 9. Right, so all I did was I took this, put it into there. Now, 2y, 9 is equal to 9. Okay, when we have this right here, and everything is excluded, then this means there is an infinite solution. So let's try this one down here. So we have 2y equals negative x plus 9 2y is equal to negative x plus 13. So if you see, hopefully you see that, oh look, I can take this negative x9, I could actually substitute in here because the two y's are kind of together. So I'd give me negative x plus 9 is equal to negative x plus 13. Then I'd say, oh, add x to both sides. That'd give me 9 is equal to 13. Since does 9 equal 13? No, it doesn't. So there is no solution. Let's go to this one. So this one, okay, this one is interesting because x plus 3y is equal to 2. So I am going to, what if I were to, I want to cancel out these x's. So what if I were to multiply this top one by negative 3? It gives me negative 3x, that's what I want. So negative 3x minus 9y is equal to negative 6. And then we have 3x plus 9y is equal to 6. Oh, well, that just makes it 0 is equal to 0. And again, that is infinite. Make sure this back one correctly. Yep, okay. Now we have a cost function. And I didn't write it all out, but basically what it says is we have a company, and the cost to create something is $35,000 a month for whatever their rental and whatever loans, whatever it is, plus 85 cents to create the item. And they sell their item for $1.55. We want to know what is their break-even point. So we want to know when is C of x equal to R of x. And the idea is if C of x is greater than R of x, that means there's a loss. That means your cost is higher than your revenue. And if C of x is less than R of x, that means you have profit. But we want to know what is the break-even point. We want to know what is this. We've done this before in a previous chapter. It's just a little bit different, looking at a different way. So we say, what is 0.85 x plus 35,000 equals 1.55 x? Subtract 0.85 x from both sides. Gives me 35,000 equals 0.7 x. Alright, so we're going to divide by 0.7, and I believe it gives us something like 50,000 equals x. So they would need to sell 50,000 for that to work. Now, the idea is my follow-up might be how much revenue is that, or how much cost is that? So what are we looking at? And in this case, you would just put 50,000 into either of these equations. That would tell us how much money that they made or how much money they got from selling, stuff like that. Okay. All right, that's it for 7.1.